for me and generally on most projects, the challenge is determining the load. Like, unless you're in the really fortunate circumstance of having a very large photovoltaic array, a very large battery, a very large generator, or some other type of significant supply side asset relative to your facility load, you're generally constrained by the amount of power and energy that you can deliver and store throughout the course of a day or throughout the course of your resiliency duration. And so identifying with the client and doing the work to figure out what the load is, how long that load needs to be resilient, does that load need to adapt? So, or can it adapt? So do we want to have a full facility be resilient for X number of days, or do we want to try to to value engineer the microgrid to provide just the minimum resiliency function with the minimum amount of supply side assets? My first exposure to area networks was very similar to that, was downtown Seattle, was actually the Seattle Aquarium. And same requirement, we had to do a minimum import relay and we had to curtail the photovoltaics. It was the only answer available to us at the time. And we also didn't really have any of the smart inverter Modbus control profiles that we do today. So we had to do it with a series of contactors where the inverter's feeder between the breaker for the inverter and the inverter itself had a series of contactors, and we would actually stage in or out the amount of photovoltaic capacity to make sure we were always doing that minimum import. I'm It's really exciting to be able to deploy more elaborate and more creative solutions these days.
Hmm.
And we'll show this, or we'll talk about this more, but we were able to achieve our net zero energy goals at the living building with the battery system and a microgrid controller. We have our grid following inverter, which is both a grid following, grid forming battery inverter. So like a multifunction inverter from your earlier slide. And initially, we had it connected without any phase transposition at all. So it was basically able to follow a negative phase rotation grid. But if you go to the next slide now, what we found was that when we island now, so the grid isolation device is open in this case, and we went to have the battery inverter go into grid forming mode, and we do this through an open transition. So we didn't notice any particular issue right at the outset where we're trying to transition from grid connected to islanded. When we're grid forming, the battery inverter is only able to, and I think this is the case at least for the battery inverter companies that I've asked recently, only able to form in a positive phase rotation sequence. So opposite of what our grid is.